Morning to everyone. Good morning. One minute. Okay. So, any doubts with respect to yesterday's class? Any doubts? Fine. Now, what we have discussed in last class is especially number of atoms. Anyone of you have tried with end-centered unit cells, number of atoms? So, what will be the answer? End-centered. Anyway, it's not there in your syllabus, but still. What is the total number of atoms? It will be 2, because whatever corner atoms, it will be 1, and end center means two opposite faces, it will be having 1 atom. So naturally 2 into divided by 2. So 2 into half, that means 2 divided by 2. So therefore it will become 1. So 1 plus 1 is 2. So therefore even for end centered it will be 2 atoms. Okay. So primitive unit cell it will be 1. So total number of atoms for primitive unit cell it will be 1, and for face center it will be 4. For end center it will be 2, and for body center once again it will be 2. Right? So that's what we can see. In each case, primitive it will be 1, in face centered it will be 4, end centered it will be 2, and body centered it will be 2. Okay? But for calculation you can expect question from these 3. End centered they will not ask. Just whether you have understood the concept or not, that's why I asked you people to go for end centered also. Okay now? So that's what we have discussed in the last class, that is calculation of number of atoms in a given unit cell. Okay? So in that case, least number of atoms will be present in primitive unit cells. More number of atoms present with respect to face-centered unit cells. That's what we can have the conclusion. Now, can anyone tell me what do you mean by a unit cell, or you can tell me what are those factors which is going to talk about types of unit cells, that is Bravais lattice, that is based on the one is edge length and another one is angles, edge angles, right? So these are the major factors which is going to decide what will be the type of or shape of the unit cell. So based on that we have total 14 types, that is called as Bravais lattice. And then we have discussed about crystal lattice, right? So when it comes to crystal lattice, it's a 3-dimensional representation of a crystal structure, where lattice point indicates the atoms or molecules which belongs to that particular crystal structure. Right? What do you mean by unit cell? These are the smallest structural unit for a given crystal lattice. Okay? Now then we have discussed about graphite and diamond. What is that difference between these two? When it comes to diamond, it is sp3. Whatever I am talking here is, it is related to diamond, which will show sp3 hybridization. Then when it comes to the diamond, with respect to the bonding, naturally it is covalent bond, which is also present in graphite. Now when it is having sp3 hybridization, what it will lead to? There is no presence of any unpaired electrons, or there is no non-bonded electrons. So due to that, what will happen? They are non-conductors. But when it comes to graphite, due to the sp2 hybridization. So it will be a conductors of electricity and it will be a soft material. But when it comes to diamond, it is hardest material, right? So everything is due to its hybridization. Major cause is due to the hybridization. Now melting point, diamond can go up to 4000 degrees Celsius. When it comes to diamond, graphite, it is also not less. It is somewhere around 3600 degrees Celsius. So that's what we have discussed about diamond and graphite. Okay now? So these are some of the concepts which we have discussed in the last class. Now we will move to the next part. Next is, that is nothing but packing efficiency. But before going for packing efficiency, some of the concepts you should understand. For example, now I will be talking about coordination number. I will be talking about coordination number in a crystal structure. For example, I have the atoms or elements. So this is called as one-dimensional arrangement. This is nothing but one-dimensional arrangement where I have shown one row of the elements. It can be atoms or elements. Right? Now I will be placing second row. Just imagine, you can imagine fruits which will be kept one above the other. It's not possible in reality, but you can imagine. We have kept second row. Now it became two-dimensional. It became two-dimensional. So like that I will have the arrangement. So two-dimensional arrangement. If you observe, this is what I can see. So whatever the pattern is present in the first row, I will keep it as A. So same pattern is present in second row also. Same pattern is present in third row also. All of you will agree? I am talking about the pattern of how they have been kept. It is exactly same. So therefore, if I go with 2D, I can tell that A. Right? Now, if I take any one of the atom, I will take this one as my interested atom. Now it is surrounded by how many atoms, or it will be interacting with how many atoms? 4. So therefore in this case I can tell that coordination number is 4. So hagadre what do you mean by coordination number? It is the number of atoms with which elements will be interacting with each other. They are nothing but coordination number. All of you have understood? So what do you mean by coordination number? It is the number of atoms with which these elements will be interacting. So that is nothing but coordination number. So in this case, coordination number will be, coordination number will be 4. Right? In this case, coordination number will be 4. That's what we can see. So this is called as square type of arrangement. This is nothing but square type, because I am getting square type of structure. Right? So therefore I can tell that square type of arrangement, two-dimensional arrangement. This is one thing. Now I will have another one. This is one dimension. Whatever I have written, it is one dimension. One row I have written. Now second row, observe it carefully. So when I am placing the second row, I am placing exactly in the between, not exactly above the lower atom. So I am placing exactly in the mid, right? Mid of these two atoms. Middle of these two atoms. That's how I have arranged. So that's what we can observe in the fruit shop, exactly how they will be keeping the fruits one above the other. Like that, they will keep it as a mountain. So same logic is applicable here. Now I will make other few rows. Okay. So down I will go. Same way I will arrange. Don't think that they are of different shapes. It is my drawing which has made them of different shapes. Okay. So now if I observe, I can tell that this is A type, one pattern is there. This is B, another pattern. And if you observe this one, this is same as A. So therefore AB pattern. So this is nothing but AB pattern. Now if I observe here, if I pick any of the atoms, I will take this one. In that case, neighboring atoms for this one will be like this. If I join the nucleus of neighboring atoms which are interacting with that particular central atom, this is the pattern I am going to get. So if I observe 1, 2, 3, 4, 5, 6. So there are 6 edges. So I can tell that this is hexagonal. Yes, Purnima, you are absolutely right. So this is hexagonal. Whatever I have written here, it is square type. And whatever I have written here, it is hexagonal. Right? So that's what we can see. Hexagonal two-dimensional arrangement. Now what is the coordination number in second type? If you take this one as first type, coordination number is 4. What is the coordination number in second type? Anyone? What should be the coordination number? Yes, it should be, coordination number should be 6. Coordination number should be 6. Okay? So coordination number should be 6. That's where I have got the 2 types of arrangements in a 2D. That's what I have got the two-dimensional arrangement. 2 types. AAA and ABA. Now before going to the next one, observe here carefully. There will be presence of empty space. There will be presence of empty space. Not a single packing can be 100%. There should be some space which will be left over. No packing can be of 100%. There will be some space which will be left over between the atoms. What is the reason? Why there will be some spaces which will be left over between the atoms? What might be the reason? My question is very simple. You can see some spaces which is left over, right? So we can see in between the atoms there are some spaces which are left over, empty space. Nothing is there. So that's where those empty space is called as voids. Those empty space will be called as voids. Now we know what we mean by coordination number. Now I am coining another new term which is called as voids. Now my question here is, why there should be presence of voids? Anyone? You can see the picture and you can tell. Okay. So Mayank suggests same repulsion in close proximity. Okay, fine. Amit, very good. That is because it is due to the shape of the atom. Since they are spherical, we have assumed shape of the atom is spherical. Now if you imagine the atoms are cubic in structure, right? Now any space will be left over? No, easily it can be packed like bricks. When you are making or constructing a building bricks will be kept. Any space will be there? No, nothing. It will be completely packed. So that is because of the shape. So here, since they are spherical in structure, there should be presence of wards, no doubt. There should be presence of the wards, there is no doubt. And people told there will be presence of the repulsion. Fine, but although there is a repulsion, there will be formation of chemical bonding, right? Chemical bond will happen although there is a repulsion. That's where during formation of chemical bond, they will come over all this repulsion and all. That's what you have studied in your chemical bonding topic, right? So VBT, valence bond theory, that's what they will tell. So in that way, there will be overlapping of the orbital will take place. Same logic is applicable here. So since they are spherical in structure, we can see some of the empty space present between the atoms. All of you have understood? So now we are clear with coordination number. Now I will go with the watts. I will go with the watts. But ice cubes also have watts. Yes, when you put it randomly, Sukruta. Yes, when you put it randomly, very good analogy I can tell. When you are talking about ice cubes, when you are putting it randomly, yes. But when you arrange it properly, right? So that's why if you are arranging it like a bricks, then there will not be any space. That's what I mean to tell. Okay, now even bricks, if you keep it randomly, there will be presence of the empty space between the bricks. Right? I am talking about keeping one above the other. So that one can be done for the bricks. But for fruits, whether you can do, whether you will be neatly when you arrange, whether all the space will be filled, no, there will be empty space. That is because of the shape. Okay, now? All of you have understood? Now I will come to important one. I can tell this is important. Okay? So that is related to watts. Because based on this you can ask, you can expect 1 mark question, or there can be a problem which I will tell. Okay? So when I am talking about the watts, go back to earlier one which I have told, AAA and ABAB. You should remember that one when I will be talking here. Imagine that you have a floor. Imagine this board as a floor. Okay? So I have placed 3 fruits or 3 cricket balls, whatever it is. 3 fruits like this on the floor. Not like this. I am talking about on the floor I have kept 3 cricket balls. Okay? Now I can say there is a presence of empty space. I will give it as a blue shade. There is a presence of empty space. Right? So that's what you can see. That blue shade is nothing but empty region which are present between the atoms. Now when I am talking about second row arrangement, when I am talking about second row arrangement, 2D, if you go to the 2D, second layer we have to keep now. So when I am talking about second layer arrangement, I will place the atom above this particular watts. Above this particular watt. So what I need to tell here is, I am talking about the arrangement where second row atoms will be placed exactly between the atoms. So same thing. Second row atom has been placed exactly between the first row atoms. So that's what we have the condition. Now you should tell me whether really this void has been closed. Whether really when I will place second row another atom or another fruit, whether whatever empty space was there, it will be closed. Any one of you? No, it will not be closed. Right? No. Yes, very good. It cannot be closed. So that's where if this is the type of arrangement, or since there, but void is not continued now, it is blocked. It is blocked by the second row atom or second row fruit. Yes, all of you are right. So that particular empty space has been blocked. It's not closed, it is blocked. It will not extend to next row also. So that's where this particular void, which is formed due to the 4 atoms. It is formed due to the 4 atoms. If I join the nucleus of these atoms, it will give the shape of tetrahedral structure. If I join the nucleus of these 4 atoms, it will give the shape of tetrahedral structure. Right? So tetrahedral, that means there will be, so like this, 4 faces, right? There will be presence of 4 space. Now face, one and one is here and another one is on the back side. So that's how we are going to get the shape. So therefore it is called as tetrahedral wards. Therefore it is called as tetrahedral wards. Okay? So why it is called as tetrahedral wards? Tetrahedral wards because there will be formation of tetrahedral shape when these nucleus of these atoms are joined, and you will get the 3D shape, right? So that will mimic the tetrahedral shape. Therefore they will call it as tetrahedral wards. Now question is very simple. How many atoms are involved during the formation of tetrahedral wards? What should be the answer? How many number of atoms are involved during the formation of tetrahedral wards? Naturally it should be 4. Naturally it should be 4. Whether I am clear? First and very important, what do you mean by wards? Wards are the empty spaces. These are the empty spaces present between the elements. Present between the elements in a crystal structure. In a crystal structure. They are called as wards. Now in the wards we have one type, that is called as tetrahedral wards. Right? Yes, all of you are right. It will be 4 atoms or 4 elements which will be involved in the formation of tetrahedral wards. All of you have understood? Okay? Now I will move to next one. I will be arranging the atoms. Once again I will place 3 atoms on the floor. 3 fruits on the floor. I will place the 3 fruits on the floor. Please imagine I am focusing on 3 fruits. There are many other fruits neighboring to these things, but I am focusing only on these 3 fruits. Okay? So now, if that is the case, I can see there will be presence of the empty space. Right? There will be presence of the empty space with blue shade. There will be presence of the empty space. Now when I am placing the second row, I will place in such a way that this one should not be closed. I will place it in such a way that this one, whatever void is there, it will not be closed. Void is there, it should not be closed. Actually, they should touch each other. Okay, so when I am placing the second row, I will place it in such a way that this one should not be closed. Now what is happening to the wards? Whether it is blocked, whether this void has been blocked when I am placing the second row. Anyone? When I am placing the second row, whether this void or empty space has been closed? No. Now it is continued to even second row also. Now it is continued to second row also. Yes, Purnima, it's not closed. Closed in the sense it is not blocked. Unlike here, although there is a void in this case, but it is not coming to the second row. It is blocked by second row atom. But here, there is empty space. But now that empty space even it is continued to the second row also. So there is a continuation. There is a continuation in first row to second row. Right? Now, how many atoms are there or elements are involved? How many atoms or elements are involved? So total 6. Yes, Manjushri. So total 6 atoms or elements are involved. Now one thing you should remember. Okay, already they gave the answer, very good. So when I am talking about 6 elements, the geometry, if I join the nucleus of these 6 elements, what will be the shape I am going to get? I am going to get octahedral geometry, right? I am going to get the octahedral geometry. If you go to valential electron pair repulsion theory, that's what we have seen. Central atom bound by the 6 elements, then it will give the octahedral geometry. Same logic. Since there are 6 elements they are involved, when you join the nucleus of those elements, it will give the shape of octahedral geometry. So therefore, it can be called as octahedral wards. Therefore, it can be called as octahedral wards. Therefore, it can be called as octahedral wards. Fine. All of you will agree? Whether I am clear? So therefore, when it comes to wards, we have 2 types. Tetrahedral wards and octahedral wards. With respect to tetrahedral wards, 4 elements are involved. With respect to octahedral wards, 6 elements are involved. All of you have understood? So now, when it comes to the size of the wards, which will be of larger in size? Which ward will be of larger in size? Tetrahedral or octahedral? Naturally, it should be octahedral wards, which will be of larger size. Octahedral wards will be of larger size. All of you have understood? Fine. Any doubts? So when I am talking about the wards are nothing but empty spaces present between the elements or atoms in a crystal structure. Right? That's where we have the wards. Now we have 2 types of wards, tetrahedral and octahedral wards. Fine. So we have 2 types of wards. One is tetrahedral and another one is octahedral. Now in tetrahedral, 4 elements are involved during the formation of tetrahedral wards, and the void will not be continued to second row because it is blocked by the second row element. Fine. And when I will join the nucleus of those elements involved in the formation of wards, it will give the tetrahedral shape. So therefore they will call it as tetrahedral wards. All of you have understood? Now when I am talking about second case, that is octahedral wards. When it comes to octahedral wards, there will be involvement of total 6 elements. There will be involvement of total 6 elements. And whatever empty space which has been formed in the first row, even it will continue to the second row also. So therefore, it is called as octahedral wards, because when I will join the nucleus of those elements which are involved in the formation of these wards, they will give the shape of octahedral geometry. So therefore, they are called as octahedral wards. Okay. So now, based on the size of the wards, I can tell that tetrahedral wards will be of smaller and octahedral wards will be of almost double in size compared to tetrahedral wards. Okay. Now, whatever equation or relation I will be telling, that will be very, very important for your exam also, board exam also, and even for your competitive exam also. Because based on this particular 3 points, you can expect the problem in the board also, in competitive also. Okay. Now, total number of atoms, total number of atoms in a crystal structure, in a crystal structure, it can be equal to n. Consider it as the n. N can be any number. Okay, so it will be equal to n. In that case, total number of octahedral wards will be, total number of octahedral wards in that crystal structure will be equals to n. It will be equals to n. Fine. But total number of wards, that is with respect to tetrahedral wards,